We're demonstrating AxiomEFI's single-click throttle by wire calibration today. Um, this took us a lot of work to get here, and we're pretty proud of it. So I've got a panel here with just a bunch of different throttle data in it. If I click calibrate here, my pedal calibration is already done. You can see it's going between 0 and 100, no problem. If I clear this calibration and then start, you'll be able to see the throttle going through its movements and figuring out the characteristics of the throttle. And we're going to figure out a number of things: the neutral position, the open and close stops, the spring tension, friction, a number of other things to try and help the throttle follow the target exactly. And like I said, single click, so it figures everything out for you. And right now it's just looking for the neutral position. You can see on my camera in the corner there, it's you can see the throttle move a little bit. Okay, now we're trying to figure out spring tension. We've already found the stops. We've tested this on, I think, 7 different throttles. I've tested a Volvo throttle, Kia throttle. This is a BMW throttle on the video. Both the Volvo and Kia are variations of Bosch throttle bodies. We've tested on a couple of different LS throttles, Mopar throttle, and a VW throttle. And I've also tested a Subaru throttle. So we've tested that the single click algorithm works on a bunch of different throttles just fine. We've also tested that it works on throttles that don't have a neutral point. So there's like a BMW ITB setup that doesn't have a neutral, and there's an Infiniti G37 one that also doesn't have a neutral. You might be able to hear what the throttle's doing a little bit there. And just so people are aware, I'm running this test using the Linux version of our software. Currently only works on X11 based distributions, but we'll be adding Wayland soon. Our software also works in Windows. We're just double checking the spring tension now that we've got friction handled. You might be able to see on the screen a bunch of different settings. This is all just the settings we use to make the throttle movement smooth through the neutral point and tune the closed loop calibration and the stops. So now what I'm going to do is I'm going to run our log viewer, or we still use Megalog viewer, we haven't built it into our software yet, but I'm going to run what's called a sweep test, trailing a live file so you can just see it actually work. We'll make that a little smaller so you can see some of that too. So you can see the target and the actual positions. We'll trail our live file. Go ahead and start the test. So this part of the test is pretty artificial. It's just doing some slow ramps and some fast ramps. But it does show you all the, a number of the different throttle parameters that control how the throttle reacts and responds. Up here at the top, we have the red, which is the actual position, and white was his target position. You can see they're pretty much right on top of each other. Here we have the individual PID terms for the closed loop control. Here we have our spring tension model, like just what that's doing at the moment. Here we have the error and the I term, which is controlled internally to a point, and down here we have just a zoomed in version of the set point, which is the target, and the process variable, which is the actual, and then the rate of change. You can see it's following pretty close, very close actually. And we're not getting any overshoot or anywhere near the stops. Okay, and that's the test done. We'll stop logging, close this, and that's it. If there are any questions, you can go to our website. I'll put the link up on the screen, and you can also go to our forum and ask us questions, which I'll also link on the screen.